Hello everyone, I'm coming back with a new project about how to generate particles using DEM method in Abaqus software. Part 2 simulation procedure. In my previous video I explained about a theoretical background about DEM method, so I suggest you first try to see the part 1 and then see part 2 about simulation procedure. Before performing this project, please subscribe my channel if you didn't subscribe my channel until now. First of all, it's necessary to create your model in Abaqus and then provide your IMP file. After that, for generating particle using DEM method, you need to modify your IMP file. So first of all, I need to explain my the CAE model. In this model, I just prepare a simple model, a box with two inlet to produce or generate particle. So I create the die 1, die W, particle 1, particle 2, and punch 2 and punch. Particle 1 and particle 2 means DEM1, DEM2 to generate two different particle. It depends on your PDF to generate a particle normal method. So please create your model what you want. Okay, and also you need to define your material property. For example, this is my material property. I use metric and this is elastic, this is plastic. And for example, for particle 1 I use this material steel. This shell model, shell homogeneous. This is particle 2, and die 1, die W, and punch is a rigid body. This is my assembly model. Okay, this is die DEM1, DEM2. This is my box, die and punch. So this is my inlet 1 and inlet 2. It's necessary to assemble your model. If you need more inlet, you can generate you can draw more inlet and assemble in your model. This is my step. I just use dynamic explicit. This is dynamic explicit. Time period is 0.1, and the other thing is necessary. I use mass scaling, a big mass scaling to do simulation fastly. So if you want, you can increase your mass scale. And also this is the my output. It depends on you, you can choose or not. And this is interaction. This is default interaction property without any property. This is particle 0.1, and penalty I use as a frictional formulation. And this is punch particle, means die particle, and this is the property, and I use general contact. Okay, and select the surface, DEM1, DEM2, DEM2 with DEM2, DEM1 with DEM1, DEM2 is master 1, and also okay, DEM1 master 1, DEM1 master 2, DEM2 master 2. Okay, and I use global property assignment. I use default property and individual property assignment. Okay, DEM1 master 1, and this is the property assignment. Okay, please create your CAE model, depend on your model. Okay, in this video I just trying to explain how to modify your IMP file to generate particles. So if you don't know how to create your model, C model, please study about it and create your CA model. And this video I just focus on IMP file, how to modify for generating particle using DEM method. Okay, and this is the load, gravity 1. Okay, from minus 98 for particle 1 or inlet 1 or DEM1, and this is for inlet 2. It's necessary to define gravity because in DEM method gravity is one of the most important thing. And this is the my boundary condition I use in Castor for my die, punch, and other thing. For inlet, it's not necessary to use boundary condition, just for die and other thing. And this is the mesh punch, die 1, die W, punch. And for inlet 1 and inlet 2, it's just it's necessary just to use one element. So this is just one element for inlet 1 and inlet 2, and for die and W in the punch is not important. And also you need to define a surface. Okay, set and surface or set. This is the point of inlet 1. Necessary to define. This is for inlet 2. This is the element set for inlet 1, and this is an element set for inlet 2 and surface. This is the surface for inlet 1. Please select this surface, inner surface, not the outer surface, and also DEM2 surface. This select this surface, inner surface, and this is master 1 for my case. This is my box. I choose the inner surface, and master 2 is the punch. This is the inlet. Select the inner one, and this is the inlet 1, and this is the inlet 2. Okay, after defining the surface and set, there is no anything in here, so go to the job and create your IMP file. Just create your model, for example this one, and then write IMP. After that you have your IMP file. Okay, this is my IMP file, job 6, and this is my modify IMP file. So I use this IMP file to explain how to modify your IMP file to generate DEM method. So okay, for this is my new IMP file. So find this is die1. It's not necessary to do anything for die1. Okay, particle 1. This is particle 1 and this is particle 2, means inlet 1 and inlet 2. So for the particle 1 I choose this information, copy this one, copy over here. Okay, I explain about the theoretical background, how to about the method. So please see my previous video and then try to modify your IMP file. So this is particle generator, name is DEM, type element type is PDT, 3D, maximum number of particle for inlet 1 I choose 1000. Particle generator inlet name is inlet 1. Particle generator mixture name is DM1, and it's necessary for us to define density and alpha. Density and alpha means how many particle you need to generate particle at the same time, and also damping, define the damping for a particle. As you know, when the particle generate using the go the at the end of a box by the its gravity, maybe you saw a splash and your particle spread around or outside of the box. So it's so necessary to define an appropriate number for density and alpha, and I use PDF1 for the size distribution of particle. And this is discrete elasticity. You need to define elastic and Poisson ratio for particle or inlet. And this is the probability density function, name PDF1, type I use a normal, you can use log normal, discrete, depends on you. This is the minimum radius of my particle, this is the maximum radius of my particle, this is the mean value of PDF, and this is the state variable or sigma of your PDF. Okay, and then you need to modify also this line. Okay, this is the particle section we define in RCE. So we copy this one and put in inset part set. copy internal, generate, and we remove internal and just use generate. Okay, and also it's necessary to remove or delete this line. Okay, inlet 1, and okay, and for this one also you need to see, and you need to put here instead of, okay, and this is material, a material section. And okay, for particle 2 also you need to modify your model. Okay, I use my IMP file. Okay, Control V. This is a DEM name. It's not important. You can choose what you can choose, write what you want. Okay, maximum number of particles for inlet 2. I just use one particle. You can add more one. And name of the particle generating inlet is inlet 2 and DEM2, and the density and alpha is different with the first one, and this discrete elasticity use PDF2, and this one mean, max, and mean value and state variable, and sigma is different. Is the first one. It depends on you. As I explained already, you can use normal, log normal, discrete with the same monosphere particle. So please use your size distribution. And for particle 2 also we need to modify this line. Control V. Okay, delete this one and also delete this line. Control B. Okay, for the punch is not to modify anything, and go down. And this is your assembly model. Okay. It's not necessary to modify anything in here. Let's go down. And modify here. This is particle 1, DM1 element. Just use particle 1, DM1 instead of this line. Sorry, DM1 instead of this line. Control V. And for the DM2 also use this line. C and Control V. Okay, and then go down. Unnecessary to modify anything also here. Okay, and this line also is so important. amplitude for flow speed, mass flow 1 and mass flow 2. I explain in my previous video, part 1. You can see the first video and understand anything about it. And Control B. This is flow speed, amplitude for flow speed, and mass flow 1 and mass flow 2. For mass flow 1, for example, when the inlet 1 generate particle, at this time particle inlet 2 usually doesn't generate any particle, and also at this time inlet 2 usually doesn't generate any particle, but inlet 2 I usually use this time to generate particle for inlet 2. So it's so important to modify your mass flow amplitude for mass flow 1 and mass flow 2 to explain how to generate particle in inlet 1 and inlet 2 at the same time. Okay, not necessary to change anything also in here. Okay, and okay, this is the interaction property. Okay, for interaction property, this is name default. Default is not necessary, so you can delete or just use a star. Okay, for particle particle okay, it's not necessary to find anything. And also you need to define something in here. I need to mention I explain in my first video. So surface interaction for particle you need to define surface behavior. You need to define stiffness. Okay, surface behavior, pressure over closure, I use Hertz method. As a default, I use 75 E6. Also, it's necessary to define for punch and particle. So we define this line. Okay, it's not necessary to modify anything here. And another thing is necessary to define something in here. Okay, dynamic explicit. The right element by element is 0.3 based on our amplitude. Okay, and also you need to add this line in here. C. Okay, particle generator flow, generator particle 1 DEM, flow speed mass flow 1, and particle generator flow, generator particle 2 DEMM, flow speed mass flow 2. And also need to define gravity based on this line, the load. Okay, name gravity 1, type gravity. Okay, particle 1 DEM1. You need to modify this line, so can control C and control V here. For contact okay. Contact also, we need to modify this line. Control C and V. Term structure, it's not necessary to add this line, just this line. Control contact, control assignment, rotational term, structural, and this is contact inclusion DEM1 DEM2 DEM2. Control C, DEM2 DEM1 C, DEM. Control V, DEM1 DEM2 master 1 DEM1 master 1 and DEM1 master 2 DEM2. Means punch is not necessary, so delete this line. And for contact property assignment, default also is not necessary. DEM1 master 1 punch particle, DEM2 control B, DEM2 DEM2 master 1 DEM1 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 and DEM2 also, and DEM1 master 2 DEM2 master 2 is not necessary, define here. Okay, and this is output request. Okay, we need to define anything here, everything is okay. Okay, and copy and then open your CE model. Okay, job 6. So create, and in source you need to select IMP file, choose IMP file, . select job 6. Okay, and continue, and then start your and submit your model to generate particle 1 and particle 2. I use a student version in this. Okay, I choose a student version, so I usually get error. So it's necessary to use your IMP file with the original one, Abaqus. So after running this model, your modify IMP file, you will be able to generate particle with 2 inlet. So I will show you my model how to generate particle using DEM method. Okay, this is my model. As you can see, I generate particle using inlet 1 and inlet 2. In this model I just use I generate particle 1000 particle using inlet 1, and just generate particle 1 particle using inlet 2. Okay, as I explained, you can increase your number of particle using inlet 1 and inlet 2, and also you can just use 1 inlet or more than 2 inlet. It depends on your model. If this video helpful for you, please subscribe my channel and also like this video, and also please introduce my channel to your friend, your colleague. Thank you very much for watching this video, and also subscribe my channel. I hope to enjoy this video. See you soon. Bye.